Automated prompt optimization with GEPA, turning prompt engineering from art into science. Let's face it, manual prompt engineering is painful. You sit there tweaking wording, testing on a handful of examples, hoping nothing breaks. Each iteration demands manual review, your judgment varies depending on when you look at it, and you can only explore a tiny fraction of the vast prompt space. Once you have multiple agents with different prompts, it simply doesn't scale. What if we could automate this? The idea is straightforward. Define clear success criteria, create a dataset with test cases, establish an evaluation function, and then let an algorithm systematically explore prompt variations. That's exactly what GEPA does. GEPA stands for Genetic Pareto Prompt Evolution. It borrows from evolutionary biology. You start with seed prompts as your initial population. Each generation you evaluate candidates against your dataset, and LLM proposes mutations based on what went wrong. Successful variants get combined through crossover, and Pareto selection keeps only the top performers. The key insight is that GEPA optimizes multiple prompts together, exploring combinations that manual iteration would never discover. This diagram from the research paper shows the complete GEPA architecture. On the left, you see the candidate pool and score matrix where each prompt is evaluated across all tasks. Pareto-based filtering selects the best candidates from the frontier. Then the system samples prompts for mutation and merging, proposes new candidates through reflective analysis, and adds improvements back to the pool. This cycle continues until the optimization budget is exhausted. Here's how the optimization loop works under the hood. First, GEPA evaluates the current candidate on a training batch and generates scores. Then it reflects, building a dataset of what went wrong. Next, an LLM proposes improved prompts based on failure analysis. Finally, the new candidate is compared against the old one on a subsample, and only accepted if it actually improves things. This cycle repeats until convergence. This visualization from the paper shows how prompts actually evolve during optimization. Starting from a base instruction at the top, each generation produces more specialized variants. Watch how the scores improve as GEPA discovers better strategies. The prompts branch and become increasingly structured, adding domain-specific reasoning steps, detailed formatting rules, and exhaustive handling protocols. This is the kind of systematic exploration no human could do manually. Let's compare manual versus automated prompt tuning side by side. Manually, you test on 5 to 10 examples, notice patterns intuitively, make changes on gut feeling, and hope for no regressions. With GEPA, you test on full datasets or statistically significant samples, systematically capture all failure patterns, propose changes from actual error distributions, and automatically catch regressions through acceptance testing. 3 benefits really stand out. First, automation. GEPA runs completely unattended, freeing your time for higher-level work. Second, efficiency. Mini-batch and subsample evaluation lets you explore far more variations than testing everything on the full dataset every time. And third, fresh perspective. The LLM proposer analyzes all failures together without anchoring bias from previous attempts. To make this concrete, the article walks through a contact information extraction task. The goal is to pull 5 fields from unstructured text: name, email, phone number, company, and job title. It's a deceptively tricky task because real-world text is messy, with multiple contacts, noisy email threads, and inconsistent formatting. The implementation uses Pydantic AI's agent class. The agent is configured with GPT-4o Mini, a contact info output type enforced by Pydantic, and a simple instruction: extract contact information from the provided text. The defer model check flag lets you define the agent at module load time without needing API credentials yet. Clean, minimal, and ready for optimization. Building the evaluation dataset is critical. You need 3 tiers of difficulty: happy path cases with well-formatted inputs, like a standard email signature; edge cases with unusual formats, such as international phone numbers or inline mentions; and adversarial cases with noisy text, multiple contacts, or ambiguous data. This spread ensures the optimizer improves on hard cases without regressing on easy ones. The Field Accuracy Evaluator scores extraction quality on a 0 to 1 scale. It only scores fields that have expected values, uses case-insensitive and substring matching for flexibility, and returns both the accuracy score and debugging metrics like fields correct versus total. This continuous scoring is important because GEPA needs fine-grained signals, not just pass or fail. The adapter is the glue that connects GEPA to Pydantic evils. When GEPA proposes a candidate prompt, the adapter parses it, injects it into the agent using agent.override, which is thread-safe and has no side effects, runs the evaluation in parallel across all test cases, extracts scores and builds detailed trajectory feedback, and returns everything to GEPA for the next iteration. Agent.override is particularly elegant. Instead of recreating the agent or mutating its state, you use a context manager that temporarily sets new instructions. Under the hood, it uses context variables, so it's completely thread-safe. Multiple evaluations can run in parallel with different prompt candidates without interfering with each other. Now for the exciting part, the results. Starting with the basic instruction, extract contact information from the provided text, the baseline accuracy is 86.88%. Simple cases like email signatures score 100%, but hard cases like noisy email threads drop to 60% and international formats to 80%. There's clearly room for improvement. After running GEPA with 50 optimization calls, the best validation score jumps to 96.88%. That's a 10 percentage point improvement. The optimized prompt is dramatically more specific, with explicit guidelines for each field, instructions to focus on the primary contact, preserve phone number formatting, and leave missing fields as null rather than guessing. GEPA discovered all of this automatically. Let's look at the per-case improvement. Simple email signatures and partial info stay at 100%, proving no regressions. International format jumps from 80 to 100%. The noisy email thread, the hardest case, improves from 60 to 80%. Even informal introductions climb from 75 to 100%. Systematic optimization works. But this isn't just a toy example. The research paper evaluated GEPA on serious academic benchmarks. These learning curves show GEPA in blue against MIPROV 2 and GRPO on Hotpot QA and Hover using Qwen 3 8B. Notice how GEPA rises steeply and consistently outperforms both baselines across the entire optimization budget. The gap is significant and sustained. Here are the final benchmark results across all 4 tasks and 2 models. GPay plus Merge achieves the best aggregate scores, plus 16 points over baseline on GPT 4.1 Mini, and plus 12 points on Qwen 3 8B. These are substantial improvements discovered entirely through automated optimization, no human prompt tuning involved. There are important best practices to keep in mind. Design your dataset carefully, covering the full difficulty spectrum. Use continuous scores from 0 to 1, not binary pass-fail. Start with 20 to 50 optimization calls to verify your setup, then scale to 100 or 200 for production. Always use separate train and validation sets to prevent overfitting, and monitor everything with Logfire for observability. Of course, there are limitations. GEPA can only optimize what you can measure, so your evaluator quality is the ceiling. Cost adds up. 50 iterations with 8 test cases means over 400 LLM calls. And the example only optimizes a single prompt. Multi-agent systems would better leverage GEPA's crossover capabilities by optimizing multiple prompts simultaneously. Looking ahead, the Pydantic team has exciting plans. Managed variables in Logfire will make prompt injection cleaner. The GEPA adapter will support optimizing structured prompt components with true genetic crossover, and the ultimate vision is online optimization, where GEPA runs continuously in production, improving prompts from real user interactions captured in Logfire traces. To recap, GEPA turns prompt engineering from a manual art into automated science. Combined with Pydantic AI for structured agents and Pydantic evils for parallel testing, you get a complete pipeline that systematically discovers better prompts than any human could find manually. The code is open source and ready to try. Thank you for watching.